In this video, we're going to discuss how to make our database tables relational, or in other words, how to separate data into smaller related tables that are linked together by a series of keys. And we'll talk about what primary and foreign keys are and how to create a relationship between the keys in the tables. And finally, we'll discuss normalization, which are the steps that we can take to best divide up the tables as we're designing them. Now, before we really get started, I want to re-emphasize that the main goal of relational databases is to maintain data integrity. Now, we've talked about this quite a bit in the preceding lessons, but now we're going to see what distinguishes relational databases over other types of databases that may have historically saved data in what are usually termed flat files. Data files are just filled with redundant and therefore possibly incorrect data. So how is this accomplished? Well, we've hinted several times that we need to create smaller related tables to kind of break the data up in some way and link these little tables together using keys. But what are keys and how do they work? There are primary keys and foreign keys, and they work together to create a relationship between two tables in our databases. So let's start with primary keys. Designating a column as a primary key means that when we need to uniquely identify a single row of data, we need to do nothing more than look at the column that's designated as the primary key. A key is a lot like a license plate on your automobile. There might be quite a few other black Chrysler minivans in the world, but my minivan is uniquely identified by its license plate. So in a pinch, if there are two black Chrysler minivans parked next to each other, I can tell which one's mine by simply looking at the license plate. The same thing is true with the database. We may have several customers who have a popular name, like John Smith, for example. So how do we tell all of the John Smiths apart, at least from a database perspective? Can we use their phone number or their physical mailing address? Well, possibly, but it's also possible for a father and a son who share the same name to live at the same address, have the same phone number, and so on. And besides, it's not really a reliable piece of information to use because not everybody has a phone number or an address. And honestly, it's not very efficient because numbers work better for this purpose than strings of characters. However, if we were to create a column called customer ID for our table and give it the identity column property, we could use it to uniquely identify one John Smith from another one. So each row would then be unique. And from a database perspective, a primary key column has a special constraint applied to it called a unique constraint. Even if we wanted to, the database wouldn't allow us to insert two records with the exact same customer ID. And this is important because we can't reliably link data between tables if we don't have a reliable way of telling each row apart. So this is why we use the identity column. It's a great way of ensuring that each row will have at least one thing that makes it distinct and unique. The second type of key is a foreign key. This allows us to imply that there's a relationship between one or more records in the second table and a single record in the first table. And so this is where a quick visual example might really help out. So here I have a very simple table called customers. You can see that I've got a first name and a last name, and I also created a customer ID. Now the intent with this customer ID column is to use it as a primary key for our table. So I'm going to use the identity property on that given column. Additionally, I'm going to designate it then as a primary key. And you can see I'll put a little key symbol next to the customer ID in the table. Next, I have a second table that I've created called orders. And I've defined a column called order ID, and my intent is to make that the primary key of this table. Now, the next field down, the customer ID column, I intend for this to be the foreign key, and I'll use this to relate the orders back to the customers. So a single customer can have one or more orders. So if we have a row in the customers table with a customer ID of 1, we might have multiple rows in the orders table that each have a different order ID but have the same customer ID, and that allows us to relate those two tables together. So I've designated the customer ID column with that little foreign key graphic, the FK. Now don't let the fact that we have an order ID as the primary key of that table throw you off, because in turn the orders table may have other tables that it's related to. Each order may have a number of order items that are associated with it. So one order can have multiple items in the shopping cart, for example. And so we would use the order ID as the primary key of that relationship, and in another table that's not shown here, we may have an order items table that has a foreign key of order ID. Of course, we haven't displayed that here. But the fact of the matter is that a table can have only one primary key, but one or more foreign keys. Now I've added one little last graphic, which is a designation from a type of diagram called an entity relationship diagram that shows that there is a relationship between these two tables that are defined, and that the nature of that relationship is that one customer may have many orders through the use of the crow's feet on the right-hand side of that graphic. Let me interject one little side note here, and that's the use of this date timestamp field. We could have just as easily called this order date time, which actually might be a little bit more descriptive. But if you ever see this term date timestamp, typically what this means is the date and time that this particular record was inserted into the database, and that's all. It's just a common convention that some developers use. So one last bit of information before we move on. When we sit down to actually develop the tables that we've designed on a napkin or on a sheet of paper or in our head using SQL Server Management Studio Express or a tool like Visual Web Developer, Express Edition, and use the visual tools for developing databases like we saw in the previous lessons, we will explicitly declare the customer ID columns and the order ID columns as primary keys. And then we'll explicitly declare and create a relationship between the foreign key and the primary keys by creating a relationship constraint, which is also known as a foreign key constraint between the two tables. And we'll demonstrate how to do this near the end of this particular video. So let's take a moment to stop what we're doing and go to Visual Web Developer 2005 Express Edition and use the visual tools to create a second table from our previous lessons example, define primary keys, and create relationships between two tables. Okay, so we're taking a look at SQL Lesson 02, the project that we originally created in Lesson 2, but have been referring to throughout the last 2 or 3 lessons. And really, for our purposes, the only thing we're really interested in is the mysample.mdf database that we added, and we created a table called Customers. Let's go ahead and take a look at that table. I'm going to right-click on the table and select Open Table Definition from the context menu. And as you recall from the previous video, we have defined customer ID and set that with a property of identity specification to yes, and set the identity increment to 1 and the identity seed to 8. But at this point, we have not really defined this as a primary key. It's our intent to use it as a primary key, but it has not been defined as such just yet. And it's very simple to do this. All we need to do is select the column in our designer view and then select set primary key from the toolbar. And now we see that we have a little key next to our column name. Now we have a primary key set on this column, and this will become very important in just a moment. So let me go ahead and save that change, that fundamental change to our database table. And then I'm going to create a new table. So let me select Add New Table by right-clicking on Tables and selecting Add New Table. And here we're going to define a couple of columns. So I'm just going to do this really quick. We know we want this to be our primary key. Now, our primary key has to have a value in it. It cannot be empty. So I'm going to have to deselect allow nulls. Additionally, we want to use this as our primary key, and as we saw from the previous lesson, that involves us turning on the identity specification. So I'm going to select yes and leave the defaults identity increment and identity seed to 1. Okay, so that should be all that we need to do for the moment with our primary key column. Now, the next thing that we want to do is create a foreign key relationship between this table and our customer table. Now, our customer table primary key is customer ID. Do I have to name the foreign key exactly the same? Absolutely not. I could make this a customer identification, customer number, customer record number, just record number, ID, whatever I want to call it is fine. But it's really a common convention to keep these names the same because it really cuts down on the confusion of what this column is and what it's being used for. So I'm going to name it the same thing. I'm going to name this customer ID. It too will be of type integer. It has to match the same data type as our customer table since that is the primary key. It can't be null. We have to have a customer for this order. We can't have just an orphaned order sitting out there related to no customer. That just wouldn't make sense. However, we're not going to turn on the identity specification. That's not the job of this particular column of information. It will reflect and use our primary key, customer ID. It'll share the same values, but we don't want every new order to have a unique customer ID because then they wouldn't match. The customer ID in this table wouldn't match the customer ID in this table. Okay, so we'll have to just come back to that concept. I think it'll be more clear in just a few moments. Then there's some other information about this table, like order date. We might have a small date time for that, and we might even save the order amount, although that's not necessary. We can calculate that on the fly. But for the purposes here, we'll go ahead and do that, small money. And we can have some other information. We'll make these all not nullable. And then I'm going to go back to my order ID column. And this one, I too want to set the primary key to the order ID. And select save, and we're going to call this orders. Okay, so at this point, there's still no relationship between customers and orders. Sure, we've defined both of the tables. We even have a customer ID column in this table and a customer ID column in this table. And our intent is to eventually set up a formal relationship between the two. But what if I decide not to? Well, if we don't do this, then there's no referential integrity. There's no data integrity between these two tables. What do I mean by that? Well, it would be easy to get into a scenario where we have an order that's not associated with a customer. Let me demonstrate how that's possible. I'm going to go to the orders table and I'm going to show table data by right-clicking on orders and selecting show table data from the context menu. And here I'm going to enter the information for a given order. I'm going to guess at the customer ID. Customer ID 21, I'm going to put in the order date and the order amount and then hit tab on my keyboard, and it allowed me to create an order. Order number 1, customer ID 21. Now what we would typically do then is say, well, who was the customer who ordered this? Customer ID 21. Let's look in the customer table. So I'm going to right click and select show table data so I can view the customers table, but there's a problem. As the data comes up, I see that there is no customer 21. I have a customer number 4, 9, and 11, but not 21. So there's no integrity enforced between these two tables, meaning that I can have an order that's orphaned, that it has no relationship to a real customer. And that's a problem. That means I have allowed bad data to enter my database. So what can I do to rectify this situation? Well, it's actually pretty simple. I'm going to close both of these tables, and then I'm going to, let's just open up one of them here. We'll open up this particular one by going to Open Table Definition, and really the only purpose in doing that was just so I can get this little toolbar back. The data toolbar allows me to do several things. We've already looked at being allowed to create a primary key. Now we can remove the primary key. We're not going to do that. What I really want to do is work with the relationships view. So I'm going to click on relationships, and this gives me a little foreign key relationships dialog box. Okay, so we want to formally define the relationship between the customer and the orders table. I'm going to show you one of the gotchas whenever you're first starting and how to resolve the problem. So let's start with that. And I'm going to go through the process of actually creating the relationship, or we're going to get stuck at a certain point. And since it is such a common mistake and can kind of be a head scratcher as you're getting started, I wanted to point this out first, and then we'll resolve the issue. So let's go ahead and create a foreign key relationship. I'm going to click the Add button on our little dialog box, and you can see that it automatically names a foreign key for us. Since it is a database object, it will have its own name, and it's not saved yet. You can see a little asterisk next to this. So as we change some properties about the relationship, that name will change automatically. We don't need to do anything. We can formally rename it if we want to here in this particular property in the property window. But what we want to do is go to the table and column specification property, select the little ellipsis button. We get a new dialog, tables and columns. Now here we want to select the primary key table and the foreign key table. And then once we've selected those tables, then we'll select the primary key and the foreign key respectively. So I want my primary key table to be the customer's table, and the customer ID would be the primary key. So that's correct. But over here we can see that the foreign key table is customers. Well, that doesn't make sense. We want the foreign key table to be orders. So how do we change that? Well, it's a read-only field. We can't really change it. Maybe I can change some dialog box. No. So this can become very confusing if you're just getting started. What I suggest is that if you find yourself in this scenario and you're just not able to change the information you need to change, and you understand which table is your primary key and which is supposed to be your foreign key, and you're not getting the results that you want, you need to back up and start over. And this is the little gotcha I was warning about a few moments ago. So I'm going to cancel, I'm going to select this, I'm going to click delete and start over from the beginning. I'm going to close this customer table because this is the source of the problem in the first place. I don't want to change anything about it, so I'm going to select the no in the dialog box that pops open. Instead, we're going to open up the orders table this time into our table definition view. Now I'm going to select the relationships button and click add. Okay, so now this time we can see that we have a different name. I'm going to again go to the tables and columns specification, click on the little ellipsis. This time I'm going to select customers as the primary key table and customer ID as the primary key. And we can see now we have pre-populated the orders table as the foreign key, and we need to change the foreign key because we don't want orders to be related to customer ID. We want to compare apples to apples. So we want to create the relationship between the customer ID and the customer ID in the two tables. We'll click OK, and now you can see I have a foreign key between orders and customers. One other little piece of information that is automatically set for us is that we do want to enforce the foreign key constraint. Yes, we could choose to ignore that, but we would have the same scenario that we described a few moments ago, and that would be counterproductive to what we're trying to achieve here. So I'm going to go ahead and click close, and that will save the relationship now. I selected the Save All button, and this says that the following tables will be saved to your database. Do you want to continue? It makes changes to both of our tables, so I'm going to select yes, that we want to go ahead and do that. Now notice that I get another little problem here, and the reason is because I have the situation that I described earlier where we have data that's not able to relate between the orders table and the customers table. So what I need to do is go ahead and shut this down, and I need to show table data, and I need to delete the offending row of data that's holding me back from accomplishing what I need to. Since there was no customer ID defined in the customer table, I wasn't able to create this new constraint because we have problems with our data that we need to correct first. So I'm going to select this row and click delete on my keyboard. I'm going to say yes to the notice that I'm about to delete a row. Go ahead and close this. And I can go back through the exercise of creating that relationship once again. and this time it allowed me to do it. Okay, so you might be wondering to yourself, what did we really accomplish by doing this? And we went to all this work, but what were the ramifications? Well, there's really two important ramifications of creating this relationship between these two tables. And let's talk about them both in terms of the data. Let's go ahead and try to recreate the example from a little bit earlier whenever we added an errant customer ID. And so let's open up the show table data for the orders, and this time let's go ahead and try to create an order for customer 21 and see what happens. And this time when we do it, we're going to get a message that no row was updated. We couldn't commit the row to the database because it violated a foreign key constraint, as you can see right here. The foreign key constraint FK orders customers. Correct the errors and retry or press escape to cancel the changes. So what would happen if we were to change this to a customer ID we know exists in our customer table? Let's go ahead and save that, and it worked just fine. Okay. Now the same can be true. The second ramification is from the other perspective, and it's probably more important, and that is this. Whenever we look at the table data here and we want to delete a customer from our database, we're going to select customer ID number 9, Brian Faley. Can we delete him from the database? I'm going to select the delete button on my keyboard, and it says you're about to delete one row. Yes, let's do it. You can't do it, again, because the delete statement conflicts with the reference constraint FK orders customers. So by deleting customer ID number 9, it would have left an orphaned row in our orders table, thereby violating referential integrity. Again, we're all about keeping the data as safe as possible by promoting a high degree of integrity with the data, and by doing this we would have deleted a key piece of information which would have made our entire data store suspect. Can we rely on this data? Well, we absolutely can't, because there's data missing. So let's go ahead and click OK. And I just want to impress one more thing on you. Let's create another order for Brian Faley just to show that one customer can have multiple orders. So let's go ahead and open up show table data, and we'll create a second order for Brian. We'll change the date and the amount, and I can create a third order for him, and so on. So one customer can have multiple orders. Any given order can only belong to one customer. This is just one type of relationship that we've enabled through this through the way that we define the tables. We could also create a scenario where multiple entities have a relationship to other multiple entities. A little more complex, and we're not going to really dive into that for the purposes of these videos. However, there are other types of relationships that are available to you, and that's based solely on how you create your table structure. Okay, so hopefully up to this point there's nothing that I've said that would completely overwhelm you, but you might have a question or two in your mind about the process that you go through to decide what fields of data belong in each of your tables. And going back to our discussion a few lessons ago about Cod, who was the father of relational databases, recall the problems that he was trying to solve and the situations that modern computing at that time found itself in, where there was a lot of redundant data. And so he came up with several steps that you could take to convert this flat file format that was common in that day to this new relational database format. And that process of those steps that you could take, he referred to as steps of normalization. And each time you applied one of the steps or rules, you would be able to say that our current database structure is normalized to third normal form or second normal form. And that nomenclature would be something that your peers would understand as you went through this process. Now, there are about 7 forms of normalization. Most people never normalize past the second or third form because it does introduce a bit of theoretical complexity into the mix. However, as you continue on in your progress and working with databases, no doubt you'll become introduced to some of these concepts and be more familiar with the steps of normalization. We're only going to cover the first 2 in this lesson. But the key is that you really don't have to memorize everything that I'm about to show you. That some of this will become second nature to you after you've seen it done, and you won't need to think so hard on successive passes at your database structure. So as I said earlier, we're going to take a look at the first 2 normal forms. And beginning with the first one, you can see that the formal definition of it is that you should remove repeating columns by creating a new table, moving the columns into the new table, and linking back to the old table in a one-to-many relationship. And so I've got a quick before and after snapshot. You can see that in the before, I've got kind of a convoluted mess of customer order. I have an invoice number column, first name, last name, first order date, first order amount, second order date, second order amount, third order date, third order amount, and so on. You can see that this would really lead to a redundant situation where you have to continue to add additional columns every time you want to insert new information about a given customer. In this case, every time he makes another purchase from your company, you would need to insert more columns at the end of his particular row of data. Hopefully you can see how inefficient that would be. One customer who purchases from you 50 times would necessitate that the other customers who may have only ordered once or twice have 48 or 96 unused columns worth of data. And that represents real space on a hard drive. It also makes reporting on that information very complicated. By applying first normal form, we take out first order date, second order date, third order date, and so on. We take out first order amount, second order amount, third order amount, and so on, and move them into their own table. You can see the after effect where we have 2 tables now, a customer table with information unique to the customer in that particular table, and then information unique to an order in the second table. And then we create a relationship, just as we've done in the previous example, between the customer ID as the primary key in the customer table and the customer ID as the foreign key in the order table. The data regarding a customer is highly cohesive. We wouldn't put in there information about a specific order because it needs to be more generalized to all to potentially include all information about a given order. Also, from an order table perspective, it's very cohesive. Just information about a single order is contained here, not multiple orders, but one order per row. So hopefully this makes sense and seems pretty obvious why we would want to do this. Let's move on now to the second normal form, and it's defined this way. Move repeating fields into a new table that contains a primary key and relate it back to the old table using a foreign key. In this scenario, you can see the danger of having Bob Tabor listed multiple times or Arnold Rimmer listed numerous times within our database table. The problem with redundant data is that you don't know which version of the data is most correct and represents the current state of that given row. In other words, as you can see, there's 2 Bob Tabor records, record number 1 and record number 3, customer ID 1, customer ID 3. One of them has him working for a company called Bobco, and the other one has him working for a company, LVS. Similarly, you can see with Arnold Rimmer, he is either working with he's working only with one company, Red Dwarf, but since we listed also how many employees does this particular account have, we don't know which version of Red Dwarf is accurate. Do they have 4,000 employees? Do they have 4,400 employees? And this is a fairly innocuous example, but it really highlights the difficulty of redundant data occupying multiple rows within a flat file. What second normal form hopes to improve on is to kind of split these out into two entities. By splitting out the company name or the company, which we're calling accounts, from the individual people that work for the company, which we're calling contacts, we can eliminate the redundancy. And when we have new information about Bob Tabor, for example, that he works for a new company, we would just simply create a new row within our accounts table and then associate him with the new account record. The same is true for Red Dwarf Incorporated. As an account, if the number of employees change as our salespeople are going through and updating information about this particular account, then we know that we have the data saved in one place, in one record, and we don't have to do some forensics to figure out which version of the data is most accurate, latest, and most pertinent to our particular query. And I went through this whole exercise of talking about normalization because while it's important to understand the fundamentals of it, I think that, as I alluded to earlier, what's more important is that you get the spirit of what's trying to be accomplished here. And that is the decomposition of information into smaller tables and the process that you go through it and the thinking that you do and how to group multiple columns of related information together in an accurate way so that your tables are truly relational and enforce referential integrity and keep your data safe. As I mentioned earlier, there are 7 potential forms of normalization. Most people don't move past the second or third form, and it's really not necessary to do that because while it's a good idea to apply some of the rules of normalization, honestly, as you get into some of the higher forms, there is such a thing as too much of a good thing. Not only does it become confusing from a design perspective, but then for those who are actually trying to use your table structure to do something meaningful, like create an application or create a report, it makes the querying of the data from the database very difficult, to say the least. So there's this old DBA saying that I heard once and I really liked, and it is normalize until it hurts. So go through the process of normalization and really think through why you're doing what you're doing, but then denormalize until it works. Denormalization is basically when you step back from that process until you get something that is comfortable and usable by you and the users of the database. Okay, so we've covered quite a bit of ground in this particular video. We talked about primary and foreign keys from a theory perspective and then demonstrated how to create those as well as relationships using the visual tools in Visual Web Developer 2005 Express Edition. We talked about how referential integrity is enforced by creating relationships between tables. And then we talked about the process that we use in order to accurately split up columns of data into a more correct form using the process of normalization. In the next lessons, we're going to move beyond the creation of relational tables and talk about how to use the structured query language to get data out of and insert data into our tables programmatically. So I hope you're enjoying this series of lessons. Hope you're finding them informative and that they're practical enough so that you can use them as you're developing your own projects. If you like this sort of training, please visit www.learnvisualstudio.net where you can download over 500 screen cam video tutorials just like this one on all topics related to .NET, including C#, Visual Basic, ASP.NET, and more. Thank you.